Last week I gave you a little homework to try to create a floating slow fade display method for our title headers. I said that I would do the same, so here's how I did mine. Floating slow fade uses the slow fade technique, except all it adds is a small bit of movement upwards for the header as it fades in. They both use the fade speed, so however long it takes to fade in is equally how long it takes to move it to its correct position. Now let's see how this works. First up, floating slow fade was added as an option to the display methods. That lets me select it from the editor window. Down in our revealing coroutine, you'll notice some changes. All of the methods now use their own sub-coroutines, simply for organization's sake. Each coroutine is a separate enumerator given the name of the display method and acts to reveal the header in its own specific way. Typewriter is the same, and they're called by yielding for the duration of the coroutine. Floating slow fade was added, and it uses the same type of sub-coroutine. It might look a little daunting at first, but it's not that bad. I added two variables, a boolean and a vector. The vector caches the original position of the header, and the boolean says if it's been cached or not. In show, we have not yet cached the position, so the cached position becomes the current position of the header. In hide, if the position has been cached, the header reverts to that position. But silly me, I never set that boolean to true after it was cached, so just make sure you set that to true when the position is cached in show. So once it starts displaying, the alpha of the banner and text is set to 0, as we did for slow fade. Then the downward offset is calculated as 25 units multiplied by the relative screen height as a percentage. It's then placed into an offset vector, and the banner's position is set to that offset. This allows us to go to the same relative offset regardless of what size the screen is. Then, for as long as the banner is not fully visible, or the banner is not yet in its correct position, we loop. During this loop, we use the slow fade method to increase alpha, and we use vector 3 to move the banner to its target position. And we yield during each loop to prevent a stall. That gives us the floating slow fade display method. Quite a lot of visual novels feature choices that allow the player to influence the story. These choices often have very small impacts, such as only offering 1 or 2 additional lines of dialogue in response, but others set off a plot reaction that conforms the story to our collective choices. People often settle for as simple of effects as possible because of the increasing programming that will need to be used to accommodate for each potential choice inside of the game. But impacting the flow of the entire story is often much more entertaining and engaging of a read, and the results are definitely worth it in the end, so get ready to add some choices into your visual novel, because that's what we're doing today. Last week we made our input screen, and that already gives us a template for the choice screen, so I'll just duplicate it and rename it to my choice screen up here. Then I'm changing the title here to something about choices instead of input. And remove this input field because we definitely won't need that here. What we will want is an image that'll act as the container for all of our choice buttons. Go ahead and parent it to the root and shape it to the region you want occupied by choices. This gives us a single parent for any potential choices that'll display on the screen. And don't forget to set the anchors as well. Next, it's important that we add a vertical layout group to this container. If you don't know what it is, a layout group automatically sizes and positions its child layout elements within available space. Making it vertical just means that any choices we put in here will appear above and below each other. Go ahead and make it invisible because we don't need to see the container, only the choices in it. Then align all the buttons in the middle center. You can think of this like text alignment. Now let's make our first choice button. Let's start with a regular button and just parent it to the root for now. Then give the button a layout element component so it can be influenced by our layout group. In order to maintain a good size, we need to check the preferred and minimum width and height. By default, the preferred width and height is set to the current size of the object, and the minimum is always set at 0 as a default. So go ahead and parent this to the container, and it'll automatically be sized and positioned appropriately. Notice we can't move it now. That's a good sign that it's working. But if I try to change any of these values over here, you'll see that nothing happens to my button. It remains static, and that's because we need to check the child control size option in the layout group. And uncheck Force Expand unless you want the buttons to extend to the entire range of the container. And now we can mess with the values to find the perfect preferred and minimum size of our buttons. You'll see as we duplicate our buttons, they automatically adjust inside of the container, thanks to the layout group. This means whenever we want more or less options, all we have to do is just add or delete buttons, and everything will look great by default. Now give that button a nice appearance with a sprite. And let's remove the text component and replace it with TM Pro. Next, we can set the spacing of the layout group. This value puts padding of a certain amount between each element. Now go ahead and remove the input screen component from the choice panel, and the header should already have the correct variables in place. Then create a script for both our choice screen as well as our choice buttons. And place the choice screen on the choice panel and the choice button script on the button itself. Jumping into MonoDevelop, we need to incorporate the TM Pro namespace, of course, to our button. Then make a variable for the text that's attached to our choice button. For convenience, also make a shorthand for the text on the TM Pro object. Then let's make a hidden public integer called the choice index. The use of this will make sense for what this value is in just a little bit. That is literally all there is to a choice button. It's just a reference to a few variables. So go ahead and assign the TextMesh Pro to the variable slot, and then jump into the choice screen script. Let's start by making an instance of this script through awake. Then replace start and update with a static show and hide function, just like we did for the input screen. It's basically going to function exactly the same way in terms of calling it. Then incorporate the UI and TM Pro namespace so we can use the right variables in this class. And to add more choices, we're going to need a reference to the choice button prefab. And we'll also want a list of all the current choice buttons being displayed, so we can get the values associated with each choice being presented. This ties into the choice index we placed on the button. The index will be its placement within this list. And let's not forget about the root of the panel. And we also need the title header. I'll make a public variable as well as a static reference, since most operations in this class will be static. After that, I want to reference my vertical layout group. This is the object that automatically sizes and positions the choice buttons based off of how many are in the screen. As we add more buttons, I'm going to want to decrease the padding so they fit more nicely. Once we actually see this in action, it'll make sense why we do this. And since I sometimes forget, let's just go ahead and assign all of the variables right now. There's our root, and the header is on the screen itself, so that'll go there. The prefab is our little button, and the layout group is the container for the buttons. Good, so during awake, we want to start off by making sure the screen is hidden, so call hide right after we get our instance. Go ahead and make a coroutine that'll reveal the choice screen and display the choices we have. I will simply call mine showing choices, and then I will make the standard references to accompany it, including my coroutine holder and the status boolean. In hide, we can now check if the coroutine is running, and terminate it if it is. Stop it with the instance since this function is static. And set the holder to null. Ensure that the header is hidden as well. And deactivate the root. Then we're also going to want to clear out all of the current choices, so we need to make a function to do that for us. This can be static, but not public, and all we do here is destroy every button game object and clear the buttons list. Now let's handle when we show the choice screen. This time we'll start by activating the root. And when we show a choice screen, we may want a title, but we'll definitely want some choices. Add a string parameter for the header title. Then we'll make use of the params keyword to allow one or more string to be incorporated into a string array as our total range of choices. So just like with the input screen, only display the header if a title is not blank. As we did below, if the coroutine is running, go ahead and stop it. Then we also want to clear the current choices here to make way for the new ones. Then we activate the showing coroutine and store it in our holder. What we should do though is add our choice array to the coroutine's parameters so we can pass it from this function into the loop. So let's come down to our showing choices and just add a string array called choices. And then where we call it and store it in our container, let's pass in the choices that was passed into this show method. Moving on, let's create a class that'll hold the data of our last choice we made using this screen. This will be used by other classes to determine what choices are made and how to react to them. What we need in here is an index. This is the choice index. This is also the index of the choice button that we click. Make it -1 to signify it has not been set yet. Also, give this choice a title. This will be the string on the choice button we clicked that the player reads before making a decision. Last is the boolean called has been made. This means the choice has been made and should only be true if the title is not empty and the index is not below 0. Okay, and now we need a function to reset this choice to its original state, thus turning has been made false again. According to what it needs to be true, all we have to do is set the title to empty and the index to -1 to reset the last made choice. Now create a public static instance of this choice so we can access it from anywhere. That static choice is going to be a reference to a public choice on the screen itself. Let's make that to a new choice. And then last choice made will simply return the choice attached to the instance. With that, let's now enter our coroutine and immediately yield so we allow the header to start displaying if one will be present. Then reset the last choice made. After that, yield until the header is finished displaying. Now let's loop through each choice given and create a button for it. We'll create one with a new function called createChoice and pass in the current choice in the iteration. This function will create a new game object from the button prefab, set the text and index to the correct value, and add the new button to the button list. We'll get our game object by instantiating the instance's choice prefab, and then immediately assign its parent to the parent of the prefab. Once we have that, the prefab is disabled right off the bat, so we need to activate this new game object to make it display on the screen. Then we'll want to cache the choice button component attached to it, so let's get that component. Next, we can set the text to the text that is on the choice button. And the choice index is the current index of our buttons list. And lastly, we add that choice to our list of choices. After all of the buttons are added to the menu, we just need to wait until the choice has been made. Now this needs a boolean, and the value will be returned true only if we're showing the choices right now and the current choice has not been made. As long as we're waiting for the choice to be made, we just need to yield until the next frame. And finally, once the choice has been made, we automatically hide the choice screen. There is one more thing I want to add. Just to make the choices look better, this will affect the layout spacing. Sorry about that. When we begin to have a lot of choices, they'll shrink to make room for others, making the padding look bigger than needed. So by decreasing the padding as the number of choices increases, we'll actually maintain a better display. So make another static function to change the spacing to match the number of choices we have. And be sure to call it after all of the choices have been created, so that way it'll adjust after we already have them on the screen. This function is going to be relatively simple. I'll log the current count of my choices as an index of I, and I'll use that to determine the spacing size. For my personal taste, if I have 3 or less choices, the spacing will be a cozy 20. Otherwise, if it's higher than 6, then my spacing will always be 1. Now, if the count falls between these two numbers, then I'll handle them with a switch for each individual increment. 20 will decrease by 5 each time, making 4 use 15, 5 use 10, and 6 use 5. Then anything higher will just use a padding of 1. Alright, great. Now we need to make sure that clicking a choice button will actually make a choice for us. So we'll need an event in the choice screen to call from onClick, or onPointerDown if you're using the event trigger. Simply add a public void called makeChoice that takes a choice button parameter. With that, we set the title and the index of the current choice to what is contained within the button. If you want to make choices through script by using titles or indexes, then feel free to do so using these two methods as examples, but I will only be using the button reference above. Now we can call makeChoice from the button trigger and pass in itself as the parameter to allow ourselves to make choices. This is only the prefab, so go ahead and deactivate this button in the scene. We should see no buttons in the game window. Now we have a fully functioning choice screen, but we need to verify that it actually works. This, of course, will use a testing script. So let's go ahead and go into the testing folder and make a new script for the test on the choice screen. From here, I set a title for the header. I won't be using start, so I'll get rid of that. And in update, I will trigger the choice screen when I press the 1 key. Since it's static, we call show directly from the choice screen class. Pass in the title for our header. And because we're using params for choices, we can just add a string for every choice we want to make. Let's change up this title to something that'll fit what I'm about to do a little better. Maybe, let's say something that we like, and I will give a choice for if we like dogs or cats. That ends up presenting this on the screen and showing a choice for dogs and cats. Clicking on one or the other will make the choice and close the screen. Now let's add another option because, maybe we like both. And now we get 3 choices instead of just 2. It'd also be good to set a highlight color over these choices if you can't see it well. A bright yellow looks good to me. And just make sure that you set it to your prefab outside of the game. Also consider playing with the preferred minimum sizes of your buttons until you find what looks best on the screen. So mess with your minimum and preferred to get something that looks a lot better like that. Now, as opposed to using multiple strings for our choices, we could also just use an array. In this case, we just populate the array with choices before sending it to the choice screen. But when it comes to actually performing actions based off of the choices we make, things get a little more complicated. I'm going to start and make an enumerator for using a type of dynamic story. I'll start the coroutine within update, but actually turn that into start, so it only starts once. And then we'll control choices affecting what dialogue displays on the screen. I'll be stitching chapters together based off of choices, so I need to monitor when I'm in a chapter. This means creating a boolean in my novel controller that returns true when I'm handling a chapter file. And make sure to set the coroutine to null at the end of the function. Remember, this is in our novel controller. By using a coroutine in my testing script, I'm stitching chapters together based off of the choice that I make. This allows me to create story branches. Each branch leads to different chapters that lead to different dialogue and events that eventually shape the whole story into a dynamic piece. You see here that by selecting the choice of index 0, which is my first choice, I enter story branch A1, whereas choosing choice number 2 at index 1 leads me to story branch B1. Then I read the appropriate chapter file based off of that choice and continue. Inside of Atom here, you can see my very short story branches as separate chapter files. Each file has a different dialogue related to the choice that leads up to it. This is a very simple approach, but it's rather good for testing on this script. So watch here as the dialogue of my starting chapter leads up to a choice. Two characters are arguing about returning back to a place of danger to warn the people of a terrible monster. And right here, Terrence gives Avira the choice of staying or coming with him. The chapter finished and the choice is presented, and I choose to go with him, and that opens story branch A1. On the other hand, if I were to replay that moment and chose to stay behind, then that would take me to branch B1, which has entirely different dialogue and will lead to a different story branch, and so on and so forth. As I said, this is a very simple example, and most choices in visual novels don't affect the story, they just affect the next few pieces of dialogue, because using story branches is a difficult and time-consuming process, as you not only craft one story, but you're making many alternative ones. As a best practice after loading a new chapter, you should yield for a frame to let the chapter coroutine start, and then immediately send the next command to the novel controller to automatically start the new chapter, rather than waiting for user input after it's loaded. This way, as soon as we make a choice, the next bit of dialogue in the preceding chapter begins. That concludes today's episode. In the next one, we're going to add everything we've done here with choices and input screens directly into our chapter files. And from there, we'll begin the final pieces of the series, making our main menu and everything else to finalize our project. Once the series is complete, there may be some bonus episodes covering additional features people have requested, but we'll be ending it off within the next several episodes. Thank you again for tuning in, and I will talk with you guys next time.